Hey guys, today we are going to be building a server in Tokio. It's going to be kind of a toy example. We're going to go through, I guess the mindset of how to start from scratch, how to actually build a server that listens on a port, responds to clients, deals with client state. So this is something I just came up with. Hopefully we can get it implemented in a reasonable amount of time without too much flopping around. All right, so let's get into it. So our server that we're going to build is going to respond to clients that connect to it and ask for the time. Now this sounds pretty simple because it is, but the twist is that we're also going to be able to let our clients specify their time zone, and that's going to add in the factor of having to store state. If you look at the Echo server, all it's really doing is piping the bytes from the client to the server, and the server pipes them back. From a standpoint of using futures and using the combinators that come in the futures crate, you're not really doing too much complex. Like there's no complexity there. It's just a lot of chaining methods together, and then it just sort of works. So we're going to try to introduce some state as sort of the next step of what do you do with the Echo server to start adding on the complexity, learning more about how you might actually build a server, a long-running server that isn't just doing, echoing the bytes back. Hopefully get the wheels turning on what the structure of something like this should sort of look like as you, build your own Tokio servers. Think about building your own servers using Tokio. We're in our Scratch directory. We're just going to jump right in. Let's make a new project. We don't want any version control because... Oh wait, no, maybe we do want some version control. We can add it later. We don't need it now. And we'll call it Tokio, I guess datetime, because we'll have the time. Tokio datetime server. Cool. All right, let's jump into this. All right, so immediately we're just going to go to our cargo config because we know we're going to need a few crates off the bat. Oh, and now you know my Wayfair email address. I work at Wayfair for anyone who's not familiar with me. We know we're going to need Tokio, and Tokio and the futures crate are both, the ones we're going to use are both the 0.1, whatever the patch release is. Futures goes up to 0.3, but 0.2 and 0.3 are not compatible with Tokio 0.1 out of the box, so we're just going to avoid that for now. That's a long history that you can look in the issues for on GitHub and get a little more clarity on, but for the most seamless path, it's 0.1 for both of them. It's going to help us out. And I think we're definitely going to want Tokio. Actually, no, I think this should be good for right now. We might have to pull in some other crates, maybe for time handling. I think the standard library has some time stuff, but we'll find out. This is going to get us going without a problem. All right, let's jump into our main. And we'll extern both of those crates because we know we're going to need them. And let's do, we're going to pull in the Tokio prelude. And, oh no, misspell. If you're not familiar with preludes, the general idea is, and I'll pull up the docs so you can see this sort of in action. Preludes are there to pull in everything that you need, like general stuff. So for Tokio, we know that you're probably going to want the future trait. You're going to want to be able to deal with streams and syncs. You're going to want things like the types for dealing with streams and syncs, like async or poll. Some of these other future-specific types, and even the futures types themselves. So what Prelude does is it sort of bundles up what we think is the most generic set of types that you're going to want to work with, have off the bat, have all the time, and you do something like this example like we just did. You can import everything from the Prelude module, which is all of these things. Async read and write, future types, sync, stream, poll, async, some of these other things, these other modules, features, streams, tasks, that all sort of gets pulled in. It just makes it easier for us to get going. But there's going to be some stuff that we pull from the futures crate directly because Tokio just doesn't expose it. All right. And you may or may not hear my cat meowing in the background early in the morning, and she wants some attention. So, just to recap, our server is going to be, it's going to listen on a port, it's going to take connections, and it's going to deal with those connections as long as the client's connected. So the first thing that we obviously need is to actually listen on a port. And just to get some black magic out, well, not quite black magic, just to get some of the boilerplate out of the way, we're just going to create a little wrapper here with and for Tokio Run. Now, Tokio Run, if you're not familiar with it, it's basically a very simple way to spawn a future, and in the process of spawning it, create the whole runtime for you. And when we say Tokio runtime, what we're actually saying is a opinionated implementation of both a futures executor and a Tokio calls it a reactor, but you could maybe think of it like an event loop. It's serving roughly the same purpose. So there's Tokio reactor, and then technically the runtime, we would call it runtime, but it's also known as the thread pool. Futures themselves are just code that doesn't do anything unless it's polled or executed. So Tokio is a futures executor. You always need that to run your tasks. But the flip side is that if your tasks, because you want to do things async, if a resource you depend on isn't available yet, you need a way to actually be notified when it is available again. So in the case of things like sockets, you need a library that can deal with the async IO sort of API, like epoll or KQ or KEvent, or KQ, epoll, IOCP on Windows, and actually then push those notifications in. So Tokio is built on top of Mio, which is a crate for doing asynchronous I/O through those operating system specific layers of epoll or KQ or IOCP, and in turn, Tokio, the types it exposes for TCP and UDP are based on the underlying types from Mio, and the reactor is also based around those. So when we execute our futures, Tokio is running those, and if we have things like sockets, Tokio is also then under the hood using Mio, which is then funneling those notifications back. So every time you're, if you have a future that wants to read from a socket endlessly, the first time you read, you might get some data, then you try to read again, there's no data, your task goes to sleep, so it has to know when to get woken up. But if you're using the normal Tokio types that are based on Mio, as soon as some new data comes in, the operating system notifies your process, it then signals the task, which is, a task is what you call a future that's been, is executing on an executor, notifies your task and it's woken up, and then it can poll again, and that third time you try to read is going to get some data. So, sorry, long winding road, but basically, we're going to use Tokio Run because it sets up the runtime for us. Just a quick and easy way to get in. What we normally do, though, is we use a lazy future, which is roughly what it sounds like. It's lazily evaluated the closure that you give it, the actual body of the function. This one we have to import. Future, lazy. Why do we need this? Why can't we just give it a future? Well, because we don't have a future to give it. Not yet, anyways. And I like this just for the way it structures it. Nothing else outside of the Tokio Run. This is just my sort of personal approach. You could define this lazy feature outside of the call to Tokio Run here, but I'm just going to do it inside for the sake of my example. So get that set up. So like we said, the first thing that our server does is actually runs a socket that's listening for connections. So we're going to do that. Now I'm cheating a little bit because I obviously am pretty familiar with Tokio. So out of the gate, I already know that I'm going to have to go import. We're going to import Tokio net, TCP listener, and my helpful language client that pops up. So we'll do TCP listener. What do we have? Should be bind, I think. Is that it? Yeah. Which means we need to give it a socket address, which I think we can do with something like, I'll have to import this in a second, but, oh wait, no. We can just do it as a string and then parse. We'll make our port 3456 because it's easy to remember. And I'm pretty sure that's going to give us a result. So we have to unwrap that, and we'll import it here because we need to import it. Socket address. And we should be able to see what's that. Oh, that's not right. Something's mad at me. No, it's just because I haven't. Address. Is that gonna make it out here? Oh, because I never. Oh no, I did import lazy. Oh, because it's not returning a future at the end. So this is a factor of the things that Tokio run and its companion function, Tokio spawn, want futures need to return futures. Which you'd think, like, how do I ever return a value? Well, you wrap it in a special future type that only ever sends back a value. And your executor actually unwraps maybe like the final future in a chain to give you the value. But if you're not returning outside of your executor, then everything is just futures. Even the return value of something that's generating, real data. So in this case, we're going to do another one, another helper function similar to lazy called OK, and you literally give this the value that you wanted to return, and now you're returning a feature that gives back a value. And the reason we do this unit type is because Tokio run and Tokio spawn don't actually ever return a value to you directly. Like, you're never asking it to run this feature and give you back the value. You're just saying, go run this feature until it's done. It wants the unit type for both the item and the error, because it can't do anything with either of those for you. Like, it's never going to pass them back, so it doesn't want them. So you just always sort of map to the unit type. But my compiler's still... Oh, because I forgot. That was silly of me. There we go. That's going to be better. It did still want the OK, but the original errors were for me more forgetting that. So, well, we do use it. That's... All right, so we have our listener. That's cool. So now we actually have to do something when it gets connections. And in this case, we're going to start to get into streams. So if you're not familiar, futures themselves are computations, a value, a return value that's yet to be realized. So they can either be pending, essentially, or done, where done is either they succeeded and they're returning a value, or they're done because they encountered an error and stopped. The streams are the exact same thing, except they never really end unless fully ended. For example, if you get an iterator over a vector, your vector is your vector is fixed sized, so it's never going to go on endlessly. But imagine a ticker stream for the stock market or something like that. Like, it clearly ends maybe at the end of the day when trading stops, but in the middle of that day, like, you don't know when the next value is coming. That's a stream. It's asynchronous. It could come anytime. It can still throw errors like a future, but it's returning items arbitrarily, and at some point it may be totally dead. So that's roughly for stream. So our TCP listener is actually a stream of TCP streams, a stream of TCP sockets. As a new client connects, it emits the value on the stream. So for streams, sorry, to rewind a little bit, what we're going to end up doing is for every client, we're going to spawn them. That way they can work asynchronously. We're not blocking one client waiting for another one in front of it. But you can only spawn a future. You can't spawn a stream per se, because it's just a stream of values. There's no computation there. So we're going to go through here, but what we're going to end up doing is actually building we're going to build this one task at first to actually run the listener. Like, we have it here, but we're not running it on the runtime. So we're going to build one task, one features chain that is going to be executed. And then inside of that, it's going to be generating other feature chains that get spawned for the client. So this first one, we'll just call it, I don't know, work. Nothing crazy here. So we take our listener. Now, listener exposes a method called incoming. And what this does is actually converts the TCP listener into a stream that we can start using to get exception, or not exceptions, accepts off the socket when clients connect. So in this case, when you deal with a stream and you want to turn it into a feature, you know, to actually do maybe a computation over every item, there's a simple for each method that we have available to us. I don't know why I didn't want to autocomplete, but we can figure that out later. And it's exactly what it sounds like. You get to run a closure every time for every item. So we'll just wrap this. Oh, because I forgot a bracket. Cool. That should be better. Oh, because I have to unwrap this as well. Complaining because I still had a result that I hadn't done anything with. Not the greatest error handling, but it would fail early, so who cares? Cool. So that same thing. It wants you to return a feature. We'll just put this down here just to sort of make the compiler happy right now. Let's see. Yeah, cool. And we'll put in our boilerplate so we don't forget what we actually mean to do with it. Tokio spawn work. Oh wait, no, I gotta. There we go. Wasn't at the right indent. All right, and it's yelling at us. Type mismatch. Let's open another so we can sort of run the compiler in parallel. Tokio datetime server. Yeah, there we go. Cargo build. Let's see what it's complaining about. This will be a race to the finish since my laptop is at 17%. Come on. Okay. Expected standard IO error found. All right. So I know what this is, but let's talk through it. So there's two things at play here. One is that Tokio spawn wants a feature with a specific type signature, or more specifically, it wants a feature with specific associated types. Features use associated types to specify the item and the error type. But there's another problem here, or potential gotcha that's good to point out. A lot of the times you'll see this when working with features, and I haven't really written non-features code in a while, so maybe it comes up there too, but I just don't remember because it's been so long. But you have this weird thing where it says something like expected type, blah, 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 found type, blah, blah, blah. And a lot of the times this can be confusing because the types are actually, I would say, reversed from what you expect them to be. So in this case, Tokio spawn wants a type of both, for both item and error, it wants them both to be the unit type. But we're giving it something that has an error type of standard IO error. That's the TCP stuff here, which is wrong. So it doesn't match. We understand that, but they're reversed. Like I certainly, when I started, didn't understand why it was saying I expected IO error. All right, so I'm giving you something that has IO error, and you say you're expecting it. So why doesn't this work? The problem is that the types are actually flipped. I think flipped in the, how you might normally actually understand them. As far as the compiler is concerned, it's right, and it is right. It's not wrong. It's just confusing. So what this is really saying is something more like, I found that I have a type signature, or I expected that because you gave me a value that has error equals standard IO error, that my return signature would have that. But actually, my return signature has the unit type for that, and this is the problem. Please fix it. So a good, I think, trick is when you get errors like this, just kind of in your mind flip the found type and the expected type. And if you think of it that way, it's like, oh, this method expected the unit type, but it found the type standard IO error. That's why it's complaining, because they just don't match up. It takes a little time to get used to that, but it's really just a matter of kind of flipping them in your mind, I think, and then it makes a lot more sense. All right, so it's mad at us for that because we Tokio spawn. So this is another sort of trick that you learn to just sort of do by default, because like I said before, Tokio spawn wants unit types for item and error. At this point, we are returning OK, this OK value with the unit type, so we've mapped there, but our error is still IO error because it comes from up here with the TCP sockets. So we just need to use this combinator called map error, which changes the error type for us. And we don't actually Maybe we do care what the error is. We'll just print line it. I don't know, let's put it up here. This is usually what you might see. Map the error early on, just in case something changes below it. And we'll say print line listener. Listener dot error. Let's debug it. And because we didn't return anything, and print line should be returning the unit type, or nothing really. Oh, and we missed a semicolon. That should. Oh, right, because I elided it and then didn't do anything with it. Sweet. All right, so that fixes it. Yeah, so anytime we get an error, we're just going to print it. No biggie there. And yeah, cool. All right. So now, yeah, all right, we're not doing anything with our client. That's fine. Let's see. All right, so now we have our client. We've gone through our listener. It comes in. This runs for every client. So the first thing we need to do for this, now that we have our connections, we actually have to build another feature now, or feature chain, whatever you want to call it, that actually deals with the client and actually runs its logic. So let's call this work 2. This is really simple. Or actually, we're not going to do that yet because we've got to do some other stuff. So we talked about the fact that our clients are going to be able to send, I don't know if I said commands, but they're going to be able to send commands to get the time and to also change their time offset or time zone, like how many hours before or behind they are from a certain point. We'll just use UTC as like the default one because why not? So we need to sort of set up a little bit of that machinery. Now, there is a crate called Tokio Codec that's also exposed through the... So the Tokio crate, again, for people who aren't familiar, is more of a facade crate. It doesn't really so much have the code itself as it's re-exporting code from all the other subcrates like Tokio runtime, or maybe runtime is baked in, but like Tokio Codec, Tokio Reactor, Clock, IO, Net, all that stuff. Those are all separate subcrates underneath the entire Tokio repo that just get re-exported. That way we can change the crates and sort of upgrade Tokio, the crate, independently, just to sort of change how we break the API. So if we have to change multiple crates to get a thing, we can sort of do it in lockstep. You don't have to worry about putting in a single PR at the same time, sort of thing. Anyways, we are going to use a codec. That's going to be the way that we pull out messages from our stream. Now, in our case, I think I'm just going to go with a line delimited codec, or not line delimited. Line delimited. So, new line delimited. This might be the place where if your codec has like a certain format, maybe the string has a really specific format. You're still using ASCII, but it's delimited and maybe even length delimited at some points, something like that. Or you could do a JSON codec. You could do something. Or you read in JSON, you spit out a custom struct, something like that. This is really where the codec infrastructure is very helpful. And you might need something more complex. You might not be able to use codec, but for a lot of people, codec will be a great way to get going. And there are 2 by default, 3 of them actually. Sorry, codecs that sort of ship with Tokio. There's a bytes codec, which is literally however many bytes it can get off the socket, or in the case of UDP, it's just a full UDP datagram. You get that back. It doesn't look for a new line or limit the length or anything like that. Although maybe you can't even tell it to limit the length. Yeah, that's just what you see is what you get. It's just using the codec sort of API. There's lines codec, which we're going to use, which looks for a new line symbol. And then everything up to that point you get back as a string. And then there's also length delimited, which is starting to get more into like true like binary protocols, your TLV type things. That's for there. It's simple enough that we've decided to bundle it in, but that's basically the end of it. A lot of other protocols that could exist, but they won't ever be baked into Tokio specifically because they're just too specific to a certain thing. But we're going to use lines codec. You can go here and look at the API, but codecs are sort of part and parcel for what you can see here is called framed, which is to let you take a object that, in this case, if you get a framed back, your object has to be both async read and write, but you can initialize either half if you want to. But what we're going to do here is we're going to take framed and we're going to give it our client socket, which is both async read and async write, and we'll give it a codec, and then we get back this framed, which now lets us start interacting with our client TCP stream as a blind streamer sync where we can send in quote unquote messages. So if your codec only deals with like a custom struct, you would be sending in instances of that struct, and then they would be getting deserialized or serialized in the codec and then sent back over the wire or pulled over the wire. In our case, it's a string, so it's just going to turn those strings into byte buffers. But for other codecs that are more specific, it's doing the translation for you between the raw array of bytes to your types and reverse. All right, so framed is under codec. So let's go. Enough talking. Let's go do something. Tokio, we're gonna import it because we know we need it. So we need both framed and we need a lines codec. And so let's do the framed new client, because remember our TXRX sort of object is the first thing. Then we have to make a new lines codec to give it the codec. That should work. Yeah, all right, that looks good. Now the next thing we do is we're actually going to split this. So another quirk of current Tokio, excluding all the async await stuff, which I won't go into, but you can look it up. You have to deal with ownership of items. So because you can't use references because of the lifetime issues associated with passing references around as these tasks maybe are executed on different executors, just aren't sure where they're going to land, you can't use references. That's something that's coming with Tokio and async await support. In some cases being able to use references, but not all of them. So you still have to kind of deal with ownership. But today, without that, everything has to be owned. And what do I mean by owned? Like, you have to give it ownership of your item. So when we say something like let framed equals blah, 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 if I actually start using framed to do reads, it consumes that to do the read. And then if I decide, the message I just got, I want to respond to it, I don't actually have access to framed anymore. So I can't actually write to framed. But you need to have access. You have to pass ownership. And a lot of these features, when they're done with their operations, they'll give you the objects back. So if I have to give you my framed object, I would get it back after my read. But if I want to do something after reading, like within the closure of here's the item you just got, I need ownership. I can't not have ownership. So what we can do is actually split framed into the read and write parts. So I believe it's going to give them to us in the read and the write order. But it's literally a helper method, not split. Split. Yeah, there we go. And we can check the documentation. Yeah, write and I had it wrong. Sorry, it gives them to you write and read order. All right, cool. Oh, actually, yeah, let's go back. You can see here where it says this can be useful when you want to split ownership between tasks, which is exactly what we're doing. We're going to split the ownership. So we split it. That's fine. We don't use any of them yet. All right, so at this point we have a read and a write part. So we can start actually reading. Now we're going to build another feature, another feature chain that's going to execute. So we'll start with Rx. Now Rx is a stream, just like our listener incoming was. But instead of using for each, we're going to use a function called fold. And for a quick introduction, if you have never used a functional language, Folding is usually an operation you see in functional languages that's used to reduce something like a vector, a list, into a single output value. Now, we're obviously not dealing with a list of like real data values like integers or anything like that. We're just iterating over a stream and we want to process them. But what fold is letting us do here is, because fold in its classical functional usage actually takes what's called an accumulator, a starting value that is supposed to be updated every time a new item comes in, and then at the end of your processing you return the final accumulator value. We're actually going to abuse this by using the fold accumulator to hold client state. And in this case, our client state is just going to be whatever they've selected to be their time zone, or in the case of never setting it, it'll be like a none, like an option type or something is probably how we'll do it. But we're going to use it to hold the state because, again, remember, we can't use references. We have to pass everything by ownership, and fold's method signature will take ownership of the state and then give it back to the closure every time an item comes through the stream, and that closure will be expected to return the value that then goes into the accumulator. So we're always passing the ownership, which fits, and it lets us hold the state, and it does that holding for us without any sort of issues of lifetime or using references. So it works perfectly for our example. We're going to put a unit type here just for the sake of being able to write a little bit more. We'll create the state in a second. So this is what it's going to look like. Something like our closure will get state as the first argument, and then it's going to get the message as the second one from the stream itself. And because fold is going to return the state of is going to return the accumulator value, it's a unit type right now, so it would sort of work, but we know it's not going to be a unit type afterwards. So we're going to, again, do our sort of map trick, because we're going to Tokio spawn this, where we will just return a unit type. Now we're doing it for map and map error instead of just map error before. We got lucky up above where we didn't have to do it, but now we will. And let's also Tokio spawn this, and let's work 2. Clear that line, and this is going to want. Well, yeah, that'll work for now. Okay. Fold definitely also wants you to return a future, same thing. But again, we're returning unit type, which it's bad right now because it has no idea what the error type should be. It can't figure it out implicitly, but that's going to go away once you actually start writing more code. So the simplest way to view this is that every single time a message comes in, we do some sort of processing with it, and it may or may not change our state. So I think what we'll do is we'll write a method that is going to take in the state and the message and then give us back our state and the response that the client should get, whether it's an error response or a good, or error response or succeed, So we'll just call this process request. Again, we're going to pass it our state. We'll give it the message because we don't need it afterwards. And we'll replace this now. We're going to write the message to client TX. So actually, I guess that's the first part of our state. How should we do this here? Yeah, so we want to keep, so again, because we need to keep ownership of our TX, we actually need to bring it into our fold. I don't think we want it in the state itself. I'm just going to put it into a tuple. We'll do it that way. So I'll fill in this initial state variable in a second with something fake, but we're actually going to pass in a tuple of state and client TX, which means in our actual closure we're going to get state and TX. And so now we've passed it in, it owns it, we get it, that's good. All right, so in our fold closure, we actually have access to it now. So client TX, or in the case of being on the closure TX, is going to be the SyncTreat, which if we well, this ain't gonna work. There we go. like I said before, it's the flip side of a stream. So instead of getting values out of it, you're sending values into it. And the basic way that you do this, once I can fly back up, is just to use send. There's also send all for sending batches or sending like an entire stream, like forwarding a stream into a sync sort of thing. There's a whole bunch of other combinators here, but really all we care about is just sending. So we have our response. We will send the response into the sync. And remember, things like this, send, if you're using TCP sockets and do the same thing, it consumes your sync, your stream, your future, and then wraps it or gives it back to you. So in this case, I don't think we can actually see it. Oh no, you can see it here. Yeah, so it consumes self, and the item has to be self sync item type, which means whatever your type, again, like syncs and streams and futures all use associated type, so this has to match. But our stream, because we used framed and split it, the sync is expecting types of item string to be dropped in, so that's fine. And it gives you this future back, send, which if we look at the implementation of future on it, the item that send actually gives back to you is S, and that's our sync type. So what it's doing is, tx send consumes tx, does its thing, consumes response too, sends it. Actually, yeah. And when whatever we get back from here, so like if you wanted to actually evaluate what happens after the send future runs, we could chain this combinator called and then, and it's going to pass a value, and that value would actually be the tx here. So we could do like another tx send something if we had to send two values or whatever. But in that case, we don't. We only have to send one response, so we don't need to do any chaining. But what we do is, because fold wants a future that gives you back, that has a return value, the item type of that matches this, we're going to use the map combinator, which returns a future that, again, just sort of gives you your OK type. Or it works like OK, it just gives you a value back. We're going to use that to actually take in tx, which is our response from send, but actually then turn it into state and tx. And we'll have to use move semantics on this closure, because state is, when it comes in here, it's still back out there. We have no access to it from the return value, so we have to move it into our closure, take ownership of it, and then pass ownership back out. A little clunky, but not too bad. And that works. Well, this is still an error because initial state doesn't exist. So let's say that initial state equals, we haven't written it yet, but we'll just call this struct client state. I think you can do it like that. Would that work? I don't know. Let's find out. Let's just wrap our type up real quick. Client state. Cool, sweet. I don't think I've ever written a naked struct like that. Now what's the problem here? Oh, no process request. Same thing. Let's just write a skeleton for it. We know it's going to take the state in, and we know it's going to take a message in. So we'll just call that request. We know it's going to be a string, and we know it needs to return both the client state and another string, which is going to be the response. And that's probably an error because it doesn't return anything. Yep, that's fine. But this goes. All right, so we've written our process request method. Now we actually have to do something with it. Everything else is in a good spot. Right. All right, so let's figure out a quick little dinky protocol. Let's say that our strings are going to be space delimited, so we'll have like the command is the first thing, then a space, then every parameter they need to take, after that, all separated by spaces. We're only going to take like one parameter, but we'll just call it space delimited anyways. All right, so this is a little boring. It's not super Tokio-y, but let's just say, so we're going to have to split our command. This means like request, I think there should be a split method. Am I wrong here? Split? Maybe. This might be like a trait impl that doesn't actually register immediately. We'll just assume that there's a method called split. Be willing to bet there is. Let's just go check the docs, I guess. Docs Rust. This will be simpler. No? Standard. String. Split. Split white space, maybe? What's that one? Split a string sliced by white space. Returns an iterator. I don't really know what the difference between ASCII white. Well, I guess some special Unicode white space. Let's use split ASCII white space because I don't know what else that other thing is. And this is, I think, simpler. Or what does this take? A pattern. Oh, let's do that. I don't want to write so much. And it returns an iterator, so we have to. What does it return an iterator of? Do we get a string back or iterator item type? Okay, so we want. Can we hold references? Does that work? Let's try it like that. Maybe it does work. We have to collect them, so we use the iterator API. Yeah, and we have to specify. It's gonna be. I'm worried that this is gonna break because we don't have lifetimes. And it's gonna not understand how long they have to stay around. Oh, that works. Cool. Whatever. All the better. All right, so we have our parts now. We split them by white space. So let's say something like, well, let's safely check if our first parameter even exists. So now we get to rate things like our error case. And we're going to try to make this that there's no weird logic that needs return. Everything will just be organized so that, you know, that the typical like Rust thing of not having to actually specify return. If your return value is the last expression, we're just going to try to keep it with that. So if there's no command, that's an error. So we always have to return the state, but we'll do like error, no command specified. But because that's a static string, you have to turn it into a actual string, owned string. That's fine. Now, let's see what happens when we actually have a command. Let's match on our command and let's immediately add a case that deals with an unknown command. That'll just be our fall through. We'll say, I think we actually want to interpolate this, and so we'll format, which gives us a string back, an own string. We'll say error, unknown command, blah, blah, blah. Yeah, cool. And we pass our string in. Nice. All right, so now let's write, well, the simplest one is we can just give them the time no matter what. So now we have to get the time, which, what does Rust give us for that? Damn, I really suck at knowing keybinds on my keyboard to move quickly. This is the worst. I don't even know how to, oh, there we go. Oh, and I'm not even in the right, there. Sorry. Let's search like a datetime thing. Oh. Date? Wow, okay. Time? Alright, it's got time. I don't know if this is time how we want. Or if you can do anything with it. No. Alright, so it looks like Rust doesn't have datetime support or robust datetime support. Let's go find a crate. that maybe does some datetime stuff. Because we know we want to use time zones. That looks like it might be useful. 2.4 million downloads. Chrono prelude. Time duration. I'm assuming this is going to work. It looks like it's probably the top crate. So let's just go import it 0.4. A little bit of a leap of faith here. Hopefully it's the right thing. Chrono 0.4. We know we need to. Oh wait, we don't need to. Extern create chrono. Oh, and it's got a prelude too. Nice. We'll just use the prelude. Sweet. So how do we actually use it? Let's go to the docs. Time. Oh, all right. So it's got some sort of a now method, which is good. Yeah. So we'll just copy this and paste it into my command line. There we go. Boom. So let's see here. We need to be able to format it. So since using the UTC, let's click on that and see what it can do. What does the time zone stuff give it? Oh wait, no, we didn't. We got a date time back. Sorry, not UTC. This is the actual value we have. Oh, that looks like what we want. Yeah, we'll take that. And it gives us a string. Sweet. This is simple. All right, so we're just going to use this method that it has built in. We got to return our state, and we're going to format a string because we want to put an indicator that the message coming back is okay, and we'll interpolate, and then we should be able to do UTC to RFC. I don't know why my autocomplete isn't completing, but I think it was 3339. Does that work? Oh, Rust language server might be behind. Swore that I added it. Chrono. Yeah, it's there. Maybe it's just mad because I haven't actually built, so it needs to pull in the crate. I think that's exactly the problem. Oh, and I never added the extern. Thought I did. What the? Use chrono prelude. Or sorry, not extern. Yeah, the prelude. Let's put that in there. That should make that work. Sweet. Yeah, and then I'm pretty sure that's right. So we'll just leave it and then deal with compiling. Cool. So now let's. Parts pop. Why does that break? Can't borrow parts as mutable. Okay, that's easy fix. And this, despite this weird. Oh no, the error went away. All right, so this can actually build. I should actually be able to run this. Sweet. I don't know why, but I never really used cargo run. I like to run the binaries by hand. Just a old habit, I guess. Let's open a new window. So I think we said our port was 3456. All right, I think, yeah, it not closing is good. Let's do get time. Oh, okay, sweet. All right, cool. So it returns the time. Nice. Let's close that. Shut that off. All right, so now we need to be able to actually hold state, and we want to hold the time zone. So let's go find real quick how this thing deals with time zones. changes the sounds like what we want. Does not change the actual. All right, so we'd give it a time zone. It would give us a new date time. That's fine. It's not a big deal. But what is time zone? Does it show implementers? We don't want UTC. We don't want local. They're going to be so maybe fixed offset is what we want. Makes it with seconds. So maybe there's not a good method to actually give it something like EST or whatever. Maybe we got to give it the manual offset. So we can do that. That's simple enough. So fixed offset. All right, let's try that. So let's make a new command called set offset. And we're just going to read in a second parameter, which will be the number of seconds, since it looks like that's what that takes. So we could actually do like match parts pop. We'll pop again, try to get our second thing. And if there's nothing, then that's an error. Let's say set offset expects offset as for index. Value. Let's just say that. Yeah, that works. Set offset expects offset value. Cool. If there is, we'll call this offset raw because now it's just a string, but we have to parse it. So we should be able to do, I think it said it was I32. We should be able to do like I32 from string, I think. Yes, that'll handle positive and negative. Cool. We'll do offset raw. I think it actually takes a string reference, so we'll just do as string. Oh. And this is I know from memory because I used it recently, it returns a result. So we'll just match on the result. So okay means we got our offset. Just boilerplate this really quick. I don't think we really care about the precise parse error. We could just say if it doesn't parse, we know something went wrong. And valid offset, I think, is simple enough. Just realized we missed a toString up here. Here we go. All right, so let's do. The fact that there's no errors makes me think that as soon as I go to compile this, it's going to freak out, but let's pretend like everything is fine. So we go through, we have our offset now. So now we actually need to store our offset in our client state. So now we're actually putting things in there. And this is what we get. I think we want an option for when there's not an offset. I think if you just connect and just want UTC time, so we'll put it as an option. So we would do something like there's this method here that gives you it back as an option, and it panics on out of bounds. So I wish there was a result type so we could actually try to create the offset and then send back an error if the value is out of bounds, but it doesn't look like there is, and I don't want to panic, so we'll just use this version, which means we won't panic and we can immediately just set the output of it right into the field. So this is fixed offset estopt, I think it was. Yeah, estopt offset. That works. And then we would send our message, which is like, okay, offset configured. I think we could say that's simple enough. And that handles that case. Now, because we have an offset, we actually have to deal with if the offset exists in our get time method, so we actually send back the right time. So let's match on state offset. We don't want to take it, so we'll do as ref. So we only get back our reference to our offset. So if there's none, that's the simplest case, which we can just move this into. We just return UTC as is. If if there is an offset, then we want to say something like, I think, let's just match up our brackets there. I think it said, was it with time zone? There we go. If we pass in by reference, we get a new datetime. So let's just call this with offset equals UTC with time zone offset, which is already a reference. We don't have to dereference reference it ourselves. And then we do the same thing. State format. Okay. So then we get with offset to RFC. Oh, nice. Cool. That does that. What's the problem here? What's it yelling about? No method as string found for. Oh, so right, because we're already using string references, it's happy with that. Does that not from? Oh, I'm missing a trait. Yeah. So we have to import the standard string from string trait to get it available, or to have it available. Oh, in initial state, we have to set our offset to none. So that. Oh, now we're mad again. Client state's not mutable. Simple enough fix. It's kind of weird when you own an object that you can't mutate it unless you specify it as mutatable, but whatever. All right, this looks good. We should be able to build this now. Let's see, and then we run it. Give it a few seconds. Connect. Come on. There we go. Sometimes it takes a few seconds to start up in debug mode. Don't know why. So we should be able to do get time. Sweet. I think get offset. Let's like set it for unknown command 3600. But that's weird. All right, so we have a bug in our command parsing. How does that? So it's reading it like it's the first parameter, which doesn't really make sense. Let's just do some quick debugging. Let's see how many things there are. Like, is it breaking the line up too much or something? Parts count. Let's put the count of the parts that it has that it's finding per line, just to make sure. Right. Okay. I'll give it a second to start. Go back to here. Right, connect. Get time should still work, which shows parts count 1, and then set offset. We never actually tried the error case. Yep, so that returns the error that it should. Parts count 1, cool. And then set offset 3600. There's our error. Parts count 2. All right, so it sees both parts. It's a weird ordering. I wonder. Let's look at Vex documentation for pop, because something's not right here. Aha! Removes the last element from vector. So I was thinking that it would return them from the front, which would be set offset first, then 3600 after, but it's not. So I think we could just actually switch this to vec dequeue, which lets you specifically add to the back and then pull from the front. But that means we need to import it because it's not there by default. That's wrong. And pop is probably, I think it's pop front for vec dequeue. Pop front. Okay. That should work. Let's find out. second. Cool. So get time, set offset, set offset. Oh, dang. Same thing, really? That's so weird. Is that what I want? Yeah, pop front. Is it? Now I'm really confused. Should be getting the thing? Or did I like not rebuild it? Oh, maybe, yeah, I guess I didn't rebuild it. That should have returned instantly. I was gonna say, if that didn't work, I would be really confused. Here we go. Let's just go straight to offset. Yay! Alright, that works again. Oh wait, crap, let's disconnect. Let's get the time without it, then let's set it. Make sure it's actually doing its job. So we got 14, 15, again 15, 15. Alright, cool, it works. And I think we should be able to set it as a negative offset. And then do get time. And it goes back, nice. Alright, cool. So we've successfully, not much error handling, not much logging, but we've successfully completed our mission. We've created a datetime server that can give you the current datetime and let you adjust the offset, either negative or positive, to affect the time for that connection. So let's go over what we learned really quickly. We've created a TCP listener that spawns itself as a Tokio, or spawns itself a Tokio spawn and runs as a task in the background. So we're asynchronously and in parallel accepting connections and then spawning them, each of them on their own task. So no one's blocking anyone else. Very simple parallelism here, very simple concurrency. We are using framed and the lines codec to actually abstract how we parse the messages from our clients. Right now it's obviously only a string that's token delimited, but you could make this whatever you want just by changing out the codec and changing your process request method to handle the specific type that the codec deals with instead of string. We're holding client state by using a fold here and passing in our state and our TX and constantly having them be provided every time the loop runs. And we've got a pretty simple setup here. Like this is, not the most complex server. 80 lines isn't the best, but we're doing quite a bit here. Holding state, responding back. I don't know what the benchmark looks like on this, but I'm sure it could actually do a pretty decent number of requests per second. So, for only 80 lines, doing pretty good. And we've gone over a lot of the basics too, using sort of the Tokio spawn, the Tokio run, the lazy feature combinator there. We've chained together features to make feature chains. We've figured out the difference between the returning unit types, or returning the unit type when you spawn versus other methods where they're actually returning things, real chunks of data. Split was a fun one. That's one you'll probably use a lot if you're dealing with socket streams. And yeah, we've built something that actually compiles and runs. That's more than just the echo example. So again, I don't know if I mentioned it before, but like we were trying to approach this like an echo server level 2, the next step up, which is mostly holding state. We're not doing anything crazy here data wise. There's no complex interactions or things that depend on each other, but holding state is definitely something you're going to end up doing in a lot of network services. Not all of them, but a lot of them. You want some sort of state, and this is going to hopefully give you an idea of what that sort of looks like in practice. I use this in my own projects that use Tokio. That exact fold trick to just keep the state around, so it can definitely work for complex projects. It's not just like a newbie tool, so to speak. But yeah, sweet. So I'll put links in the description. I'll put this in a GitHub repo. Again, it's really simple, but if you want to follow along with the code or go back to it at some point as an example reference, that'd be great. And hopefully we can get some more videos going, exploring some more complex topics. Maybe things like dealing with protocols, something like that, writing your own features and streams is another one. But yeah, thanks for watching. Thanks for listening. Hopefully you got something out of this. And thanks for using Tokio. Stop by and check us out on the Gitter chat room. Super friendly. Hope to be able to help you with whatever problems you're having. Yeah, have a great day. See ya.